Welcome to this channel, and in this video we're going to be looking at quadratic theory part 3, right? And it's going to be basically based on what we looked at in part 2, where we looked at how to determine a discriminant of a quadratic equation and then how to use that value to tell us what the nature of the roots is, that whether it's real, imaginary, stuff like that. So in this video, let's look at the application of that. Let's say I'm given this question now that says, if x squared negative kx plus 9 equals to 0 has real and equal roots, then the value of k is... So this is a question you could be asked, very important, Math 101. So all you simply need to do is to follow the principle. Please, if you've not watched part 2, please do also watch it. Right, so all you simply do is to apply the principle, which says that for a quadratic equation to have an equal roots, what happens? That means that b squared negative 4ac will be what? 0. So that's the same thing we'll apply here. So what is our b? Negative k, right? Negative k. That means negative k squared minus 4 into what? A, which is what? 1, into what? C, which is 9, is equal to 0. Negative squared is going to leave us with positive, and then we have k squared negative 4 times 1 is what? 4, right? Times 9, which is what? 36. So k squared negative 36 is equal to 0, right? So the negative 36 could move to the right hand side and becomes k squared is equal to 36. And then we find the square root of both sides. That will be square root of k squared is equal to the square root of 36, right? So what's that now going to be? K is equal to the square root of 36, which is what? Plus or minus 6. So those are the two possible values of k for which x squared negative kx plus 9 has real and equal roots. I hope you understand. Just follow the principle. B squared negative 4ac equal to 0 and then solve the resulting equation. Now see this question. I got this from a past question, Math 101, and it says, if 4 plus m x squared plus m plus 1x plus 1 is equal to 0 has equal roots, then m is equal to what? So what do you do? Follow the principle that says that what? B squared negative 4ac has to be equal to what? 0 for the roots to be what? Equal, right? So what's our b in this case? Our b is what? M plus 1. What's our a? 4 plus m. And what's our c? Our c is 1. So directly substituting, we're going to have 4 plus m all squared negative 4 into what? Sorry for the mistake. Our b is m plus 1, right? So that will be m plus 1 all squared negative 4 into a, which is what? 4 plus m, into c, which is what? 1, and that should be equal to 0. So an expansion of m plus 1 all squared, it will be what? M plus 1 into m plus 1, which is what? M squared plus m plus m plus 1, which is what? M squared plus 2m plus what? 1. So on substituting, we now have m squared plus 2m plus 1 minus 4 into what? 4 plus m should be equal to 0. On continuous simplification, what do we have? M squared plus 2m plus 1 minus 4 times 4 is negative 16. Negative 4 times positive m is negative 4m equal to 0. You get? So that will be what? M squared plus 2m negative 4m is what? Negative 2m, right? And then 1 minus 16 is negative 15 equal to 0. And plus negative is what? Negative. So that's m squared negative 2m negative 15 is equal to 0. Do you understand? So the next step now is to solve this quadratic equation that's been generated, so that you now get the values of m for which it has what? Real and equal roots. So what you simply do is to think of two numbers that you add, that will give you what? Negative 2, and that you multiply, that will give you what? negative 15. So looking at factors of 15, we have 1, 3, 5 and 15, and the two possible combinations that we could use to achieve negative 15 are negative 5 and positive 3, because negative 5 plus 3 is negative 2, right, while negative 5 times 3 is negative 15. So on solving by factorization, what do we have? M squared negative 5m, right, plus 3m minus 15 is equal to 0. So what's that now going to be? Factoring out m, that will be m into m minus 5. Factoring out 3m divided by 3 is what? M. And negative 15 divided by 3 is negative 5, right? So you can now bring this together. Sorry for that. So bringing it together, what do we then have? We now have that m plus 3 into m negative 5 is equal to 0. And then on solving this, we'll say m plus 3 is equal to 0, or m negative 5 is equal to 0. So the positive 3 crosses over. It becomes m is equal to negative 3, or m is equal to what? Positive 5. So these are the two values of m for which 4 plus m, or x squared, plus m plus 1x plus 1 equals 0 has equal roots. Do you understand? So all you simply do, follow the principle that says b squared negative 4ac and then solve the resulting equation. Do you understand? So let's take this question now. If you are given x squared 2x squared plus p plus 1x plus p equal to 0, and it has equal roots. The values of p is or are, this is a question. So what do you do? Follow the principle. B squared negative 4ac should be equal to 0. So that means that what? P plus 1 squared minus 4 into what? 2 into what? P, which is c, is equal to 0. That will be p plus 1 squared. Negative 4 times c is what? Negative 8p should be equal to what? 0. Then on expansion, what do we have? P plus 1 squared is equal to p plus 1 into p plus 1, which is what? P squared plus 2p plus 1. You grab. So that will be p squared plus 2p plus 1, negative 8p should be equal to what? 0. Then with this, what will you then have? P squared negative 6p plus 1 is equal to what? 0. Then can you think of two numbers that you add that will give you negative 6 and you multiply, that will give you positive 1? So look at factors of 1. I don't think any number that you could actually think of, right? Because factors of 1 are is 1 alone, right? And there's no possible combination such that you get. So you use the quadratic formula, which says that negative b plus or negative square root of b squared negative 4ac over 2a is equal to what? X. So what's the b? That will be negative negative 6 plus or negative square root of what? Negative 6 squared negative 4 into 1 into 1, right? Over 2 into 1. Do you get what I'm doing? So negative negative 6 is what? That's 6 plus or negative square root of 36 minus 4 times 1 times 1 is 4 over what? 2. So that will be 6 plus or negative the square root of 32 over 2. Do you get? So that's value of p, right? So this is simply the answer. 6 plus or negative square root of 32 over 2. And then you can notice that we can simplify this root 32, right? Because square root of 32 is the same thing as what? Square root of 16 times 2, which is the same thing as square root of 16 times square root of 2, which is what? 4 root 2. Do you get? So we can write p as what? P is equal to 6 plus or negative 4 root 2 over what? 2. Do you grab? So we can divide each term by 2. That will be 6 over 2 plus or negative 4 root 2 over 2. And then on dividing through, we'll have p is equal to 3 plus or negative 2 root 2. Do you get? I just wanted to bring up this question so that you'll be able to do it in case if maybe what you're given to you cannot actually factorize or stuff like that. Do you get? So p is 3 plus or negative 2 root 2, which implies that p is 3 plus 2 root 2, or what? 3 minus 2 root 2. And that is the answer to the question, right? So let's take this miscellaneous question now. 7r plus 1 x squared plus 5r negative 1x plus r equal to 1 is a quadratic equation. Find the values of r for which I it has equal what? Roots. I it has real and distinct roots. I imaginary roots. Very important. So what do? Follow the principle that says that what? If a quadratic equation should have equal roots, then what happens? That means that b squared negative 4ac should be equal to what? 0. So let us write down the equation we're given. Please, I'm encouraging you. Do well to subscribe to this channel by clicking the subscribe button. It's free of charge so that you get more videos, right? So that this channel will continue to grow. Share and like this video. So let's continue. So the original equation we're given is what? 7r plus 1 x squared plus what? 5r negative 1 plus r equal to 1. But you know that the general quadratic equation is given by what? Ax squared plus bx plus c equal to 0. But this is equal to what? 1. So you take this one backwards and it becomes what? 7r plus 1 x squared, sorry, this is x, plus 5r negative 1x plus r negative 1 is equal to 0. Do you get? So what are you now applying here? You're going to apply what? That b squared negative 4ac should be equal to 0. So what's b? 5r minus 1 all squared minus 4 into what? A, which is 7r plus 1 into c, which is r minus 1, right? Should be equal to what? 0. So this is the equation you will solve. So you must be very careful. So first of all, let's expand 5r minus 1 all squared. That will be what? 5r minus 1 into 5r minus 1, which will be what? 5r into 5r minus 1 minus 1 into 5r minus 1. And that will be 25r squared, right? That's 5r times 5r minus 5r minus 5r minus 1 times minus 1 is positive 1. That will be 25r squared negative 10r plus 1. Do you grab? Then moving on, remember we still have negative 4 into 7r plus 1 into what? R minus 1. So let's simplify 7r plus 1 into what? R minus 1. Do you get what I'm doing? See you. So that's, we've expanded 5r minus 1 all squared. Now is to resolve this part. You get? So an expansion of 7r plus 1 into r minus 1, what do we have? We'll have r into 7r plus 1 minus 1 into 7r plus 1, and that will be 7r squared plus r, because r times 1 is r, minus what? 7r. Negative 1 times positive 1 is what? Negative 1. You get? So that will now be what? 7r squared negative 6r, because r negative 7r is what? Negative 6r minus 1. You get? So combining it with the 5r negative 1 all squared, what are we going to have? We're going to have 5r negative 1 all squared. I just want to write it out, so bear with me. Minus 4 into 7r plus 1 into r minus 1 equals 0. And on expansion of this, we got 25r squared negative 10r plus 1 minus 4 into, on expansion of 7r plus 1 into r minus 1, we got what? 7r squared negative 6r plus 1 then equal to 0. Then on expansion of this, what are we going to get? 25r squared minus 10r plus 1. Negative 4 times 7 is what? Negative 28r squared. And then negative 4 times negative 6 is positive 24r. And then negative 4 times 1 is negative 4. Everything equal to 0. So taking this and this, 25r squared negative 28r squared is what? Negative r squared. And then negative 10r plus 24r is what? Positive 14r, because it's the same thing as 24r minus 10r. And then 1 negative 4 is what? That's 1 minus 4 is negative 3, right? So equal to 0. So we can multiply through by negative, and that will be 3r squared negative 14r plus 3 equal to 0. And multiply through by minus. So we then solve this quadratic equation. We look for two numbers. So there is a mistake here. On expansion of this, we had minus here, right? This is minus, not plus. And minus minus is what? Plus. So this is plus 4. So 1 plus 4 is 5, right? So this is plus 5. You get, so let me remove this. So what we have is negative 3r squared plus 14r plus 5 is equal to 0, which is same as 3r squared negative 14r negative 5 equal to 0, because I'm multiplying through by minus. I hope you are not lost. My mistake was that after expanding this, and we got 7r squared minus 6r negative. When I came here, I put plus. Now I've changed it to negative. So 6 negative times negative is positive. That's why it's here. And 1 plus 4 is what? 5. So hope you're not confused. So from here now, we solve the equation. We look for two numbers that we add such that we're going to get what? Negative 14. And when we multiply, we're going to get what? Negative 15, because that's 3 times negative 5, which is negative 15. So if you look at factors of negative 15, you have 1, you have 3, you have 5, you have negative, yeah, all these things are factors. So in the case of negative 14 are two numbers you add that will give you negative 14, and that you multiply, that will give you what? Negative 15 is what? 1 and what? Minus 15. Why? Because 1 negative 15 is negative 14. That's 1 minus 15 is negative 14, and 1 times negative 15 is what? Negative 15. So that will be 3r squared plus r minus 15r minus 5 is equal to 0. Then on factoring out r, that will be r into 3r plus 1 minus 5 is common to the 2. That will be 5 into negative 15r divided by negative 5 will leave us with 3r. And negative 5 divided by negative 5 will leave us with positive 1 equal to 0. Then bringing these two together, that will be what? R minus 5 into 3r plus 1 is equal to 0. Do you get it? So from this point now, we can now solve this equation as what? R negative 5 is equal to 0, or 3r plus 1 is equal to 0. You get? So that means r, the negative 5 crosses over, becomes what? Positive 5, and then or 3r, the positive 1 crosses over, becomes 3r is equal to negative 1, and then dividing through by 3, we'll now have that r is 5, or r is equal to negative 1 over 3. So these are the two values for which 7r plus 1x squared plus 5r negative 1x plus r equal to 1 has what? Equal roots, right? So the second question, what does the second question say? It says, for what values does it have real and distinct roots? For a quadratic equation to have real and distinct root, what does that imply? It implies that b squared minus 4ac, if you watch part 2, should be greater than what? Should be greater than 0. So following the same principle, what we have, it will be what? 5r, yeah, I'm right, that's 5r negative 1 squared minus 4 into a, which was 7r plus 1, into what? R minus 1, which was the c, and this should be greater than 0. Do you get? So I don't have to start solving again. We have already gotten the value, as 3r squared minus 14r minus 5 equal to 0. Do you get? So I don't need to bother myself again. So that's 3r squared minus 14r minus 5, right? But what happens here? Because remember that we multiplied through by minus, so do you get? So what was the initial expression we got? I hope you are watching so that I don't make mistakes. When we were done simplifying, we got negative 3r squared plus 14r plus 5. Then to now make it easier, since it's an equation, we multiply through by negative, that is minus 1, and this is what we have. But in this case, know that this is an inequality, so let's still write it down. 3r squared plus what? 14r plus 5 should be what? Greater than 0. Do you understand? So for an inequality, if you are multiplying through by minus, what happens? The sign must change, isn't it? Do you understand? The sign will change. So that will now be 3r squared negative 4r, 14r, negative 5 should be what? Should be less than 0. So now on solving this, what will you get? We factorized this before now and we got what? We got r minus 5. See it here. R minus 5 into what? 3r plus 1. R minus 5 into 3r plus 1 is less. So your job is to solve this quadratic equation, and you are not intended to stress yourself. Once you are given a quadratic equation, a quadratic inequality, what do? Equate each component to what? 0. If you equate r minus 5 to 0 and then 3r plus 1 to 0, that will be r is equal to 5, or what? 3r plus 1 is equal to what? 0, which is what? R is equal to what? Minus 1 over 3, isn't it? So now draw a number line. Do you get? Starting from here, the origin. This is negative infinity, this is positive infinity. Do you get? So let's say here is 5 and let's say here is negative 1 over 3. So you will test each of these regions. You will test for values less than minus 1 over 3, values in between minus 1 over 3 and 5, and values greater. And the one thing here is that you cannot test at this. If you test at this point now, that's negative 1 over 3 and 5, you will see that the output will be 0, but we are looking for values what? Less than 0. I hope you get my point. If you start from this point now, minus 1 over 3, if you substitute minus 1 over 3 in this equation, you have 0, and 0 is not less than 0. Do you get? So minus 1 over 3 will not be included. But now if we test for any value less than minus 1 over 3, for example minus 1, if we test for minus 1, what we have? Minus 1 minus 5. Are you getting the substitution I'm making? Into what? 3 into what? Minus 1 plus 1, and that will be what? Minus 6 into minus 3 times minus 1 is minus 1, right? Minus 3. The minus 3 plus 1 is minus 2, and minus 6 times minus 2 is positive, but we are looking for values less than, so this region is wrong. Do you get? So now let's test for values in between minus 1 over 3 and 5. For example, 0. If you substitute 0 in this stuff, it will be what? Watch here. It will be 0 minus 5 into what? 3 into 0 plus 1. Do you grab? So that will now be minus 5 into what? 1, which is what? Minus 5. And you can see that minus 5 is less than 0, isn't it? Do you get? So that means this region is among. Now, at x equal to 5, you see that the expression will be 0, right? Because if you do 5 minus 5 into 3 into 5 plus 1, that will be 0 times. And 0 is not less than 0. So if you test for any value greater than 5, what happens? For example, 6. If we test for 6, what are we going to have? It will be 6 minus 5 into what? 3 into 6 plus 1. Do you get? That will be 1 into 3 times 6 is what? 18 plus 1 is what? 19. And 19 is positive. So this region is also what? Bad. So what is your final answer? minus 1 over 3, comma 5. This is the answer to it. Remember, it's not like the other one where I said it could be minus 1 over 3 or 5. This bracket is implying that we are the values of r for which it has real and distinct roots is what all values between what minus 1 over 3 and 5. I'm using parentheses. If you watch my videos on functions, I'm using parentheses because minus 1 over 3 and 5 are not included. We are just concentrate values in between minus 1 over 3 and 5. Minus 1 over 3 and 5 are the values for which the equation will have what? Real roots. Real and distinct roots. So the last question says, for what value will we have imaginary roots? That means that b squared minus 4ac should be what? Less than 0. And what did we get as b squared minus 4ac? Look at it here. We got what? Minus 3r squared plus what? 14r plus 5. So that means that minus 3r squared plus 14r plus 5 is what? Less than 0. So if we multiply through by minus, the sign will change. That will be 3r squared minus 14r minus 5 should be what? Greater than 0. Do you get? So on factorization, what did we get? We got what? R minus 5 into what? 3r plus 1. That means r minus 5 into 3r plus 1 should be greater than 0. So this is now the quadratic inequality you will solve. So what do? Equate each component to what? To 0. That will be r minus 5 equal to 0 or 3r plus 1 is equal to 0. So that means that r is equal to 5 or r is equal to what? Negative 1 over 3. Draw a number line. Here is 0, here is positive infinity, here is negative infinity, right? Let's say here is 5 and here is what? Negative 1 over 3. Now test in each region. You will notice that these 2 points, the function will be 0, because if you substitute 5, you have 0 which is not greater than 0. So test for any value less than minus 1 over 3. If we test, for example, minus 1, it will be what? Minus 1 minus 5 into what? 3 into minus 1 plus 1. Do you get? Should be greater than 0. We are testing it. That will be minus 6 into what? 3 into minus 1 is what? Minus 3 plus 1, which is what? Minus 2. And you can minus 6 times minus 2 is what? Positive 12, right? Because minus times minus is plus. And since it is greater than 0, this region will be acceptable. Do you get it? Then if you test for any value in between minus 1 over 3 and 5, for example 0, if you substitute 0 in the inequality to be what? 0 minus 5 into 3 into 0 plus 1. We are testing it. That will be 0 minus 5 is minus 5 into what? 3 into 0 is what? 0 plus 1. That's minus 5 times 1 is what? Minus 5, which is negative. So this region is what? Bad. Is wrong. Then if you test at 5, you see that it will be 0, which is not part of it. Then if you test for values greater than 5, for example 6, 7, let's test at 7. That will be 7 minus 5 into what? 3 into 7 plus what? 1. And you can see that this is what? Positive. So this region is also what? Accepted. So what will be your final answer? The set of values for which r is what? Has what? Imaginary roots is what? See how I'm writing it. From negative infinity to what? Negative 1 over 3. I'm closing the bracket. Because negative 1 over 3 is not included. Union what? 5 to what? Infinity, because 5 is not included. So we are looking at values less than minus 1 over 3, excluding values in between. That's why we now moved with union 5 to. Then we are not including 5. That's why I use the parentheses, and then 6, 7, 8, 9 down to infinity. So these are the sets of values for which the equation has what? Imaginary roots, or you could say imaginary and distinct roots. Do you understand? So we'll take one more, and then that will be all. for this video. So let's say you are given this question now. X squared minus kx plus 16 equal to 0. And the question in exam says find the set of values of k for which the equation has imaginary roots. This is our last question. So if you should have imaginary roots, what happens? That means that b squared minus 4ac should be less than 0. So what is our b? Negative k all squared minus 4 into a, which is what? 1, into c, which is 16, should be less than 0. So negative k all squared, negative and negative is positive, then we have k squared minus 4 times 16 is what? 64, less than what? 0. And then you can find out that you can factor this out using difference of two squares, because this is same as k squared minus what? 8 squared is what? Less than 0. So you can write it as what? K plus 8 into k minus 8 using difference of two squares should be what? Less than 0. So what do you do next? Equate each component to what? To 0. That will be x plus 8 is equal to 0, x minus 8 equal to 0. That means x is what? The positive 8 shifts is negative 8, or x is what? 8. Draw a number line. Here is 0, here is positive infinity, here is negative infinity. Let's see, here is minus 8, let's see, here is 8. If we test at minus 8 or at 8, you will see that the output is 0, and 0 is not less than 0. For example, if you substitute 8, it will be 8 squared minus 64, which is what? 0. But we are looking for values of k such that this will be less than 0, isn't it? So if we test for values less than minus 8, for example, minus 9, if you substitute minus 9 in k squared minus 64, what will you get? Minus 9 squared minus 64, that will be what? 81, because minus times minus is plus. Then that will be 81 minus 64, which is what? I think that should be 17, right? That should be 17, and 17 is positive. But we are looking for values for which it will be what? Negative, which is less than 0. Do you get? So this region is wrong. Do you get? Then test for values in between. Test for values in between. So if you substitute 0 in k squared minus 64, what will you get? 0 squared minus 64, right? Which is negative. And we're looking for negative values, right? So this region is okay. Then at 8, you know it will be 0. So let's test for values greater than 8. For example, 9, 10. If you substitute 10, it will be what? 10 squared minus 64, which is what? Positive. Do you get? So this region is bad because we are looking for negative values. So what's your answer? The sets of values of k for which the equation x squared negative 4 kx plus 16 equal to 0 has imaginary roots is what? Minus 8. That's between minus 8 and 8. Any value in between minus 8 and 8, the equation will have what? Imaginary roots. Do you understand? So this is all you simply need to do when you are given a question that maybe they are now using k. Use the procedure. If it's imaginary, that means b squared minus 4ac is less than 0, right? If it is real and equal, that means that b squared minus 4ac is equal to 0. If it is real and distinct, right, that means b squared minus 4ac is greater than 0. So in this case, you see what it did? This is a range of values. But if, for example, this question we just solved now, that said k squared minus kx plus 16, they say find the set of values of k for which the equation has equal roots. You will just solve this equation, that's k plus 8 into k minus 8, and do what? Equate it to 0. And that means that k is equal to minus 8, or k is equal to what? 8. These are the two values. But in this case, we are looking at a range. So you can see because of this bracket, it's not the same thing. We are looking for values in between. in between what minus. That's what this stuff means. So thank you so much for watching this video. Right, you can see my number on the screen. If you have any questions relating to stuff like this, please do well to contact me, ask me questions. And then also do not forget, if you've not subscribed to this channel, please do well to click the subscribe button, like and share this video. Thank you so much for watching.